welcome back to my channel. So today we are treating what we know as atomic structure. So let's look at electronic configuration. After electronic configuration, we want to look at the rules governing electronic configuration. So we have this guy which is called electronic configuration. So what's electronic configuration? Is the arrangement of electrons of an atom of an element into atomic orbitals. So it is the arrangement of electrons of an atom of an element into atomic orbitals. All together. So that is as simple as that. All right. So there are rules governing this electronic configuration. You don't just write electronic configuration of orbitals anyhow. There are rules governing it. So we have three rules. Governing electronic configuration. We have three rules governing electronic configuration. So what do we have? We have one, Aufbau's law. So what does Aufbau's law, what does it state, or what does it say? Aufbau's law states that electrons are arranged starting from the lowest energy orbitals to the higher energy orbitals. That in filling electrons are arranged into orbitals of lower energy before moving higher up. So let's put it in a better way. This states that electrons are added to orbitals starting from the lower energy orbitals or from the lowest. Let's put the lowest. So Aufbau's law states that electrons are added to orbitals starting from the lowest. This is wrong. Starting from the lowest energy orbitals to the higher energy orbitals. So Aufbau's law states that electrons are added to orbitals starting from the lowest energy orbitals to the higher energy orbitals until all the electrons are filled up. So what are we saying here? We have energy orbitals. Are we together? We have energy orbitals. Are we together? So how do we know which one is higher? How do we know that which one is small? So we have something. We have 1x, 2x, 2p. Mainly we have 4 orbitals, which are s, p, d, f. Now we now know that if you have to fill an electron into s, p, d, f, how do we know which one is small? How do we know? Do we know if 1s is smaller than 2s, if 2s is bigger than 2p? Are we together? So that's what I want to do here now. But we have mainly 4 orbitals, which are s, p, d, and f orbitals. Now we want to know in terms of their energy. Those orbitals, they have their energy. Are we together now? So we already said that Aufbau's law states that in filling electrons, we should start from the lowest energy orbitals up until the higher energy orbitals, until we've existed all the electrons that are needed to be filled up. So there's a table like this: 1x, 2s, 2p, 3x, 3p, 3d, 4s, 4p, 4d, 4f, 5x, 5p, 5d, 5f. I was gonna. So that's that like that. So this is how you do it. You take your arrow down. Let me use a blue pen down. Take your arrow down. take your arrow down. You take your arrow down. So if you want to be judging by this now, we have 1x, 2s, 2p, 3s, 3p, 4s, 3d, followed by what? 4x, 3d, 4p, 5x. Are we following? 1x, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5x. So this is in terms of what? Energy orbitals. One would expect that 3p should come 3d, then 4s, 4p, 4d. Can you see? So that's why we need this little table that you guys see here. So you're not going to assume anyhow that okay, 1s, 2s, 2p, 3s, 3p, 3d, 4s. No. You take it down like this. So that means this 1s orbital is the what? Is the ground state, followed by what? 2s. That means you're moving higher up. 1s is less than 2s, less than 2p, less than 3s, less than 3p, less than 4s, less than 3d, less than 4p, less than what? 5s. So that's what our verse is saying, that okay, if you want to fill electrons into orbitals, are we together? We should start from the what? Lowest energy orbital to the what? Higher energy orbitals, until all the electrons you want to fill are what? Exhausted, or they are filled up. So what are we trying to say there? For example, now let's fill hydrogen. Let's fill let me give nitrogen. So we already know hydrogen is 1, nitrogen is 7, right? We know that hydrogen is 1, nitrogen is what? 7. Now let's fill. So which orbital are we going to start with? 1x, and this is proton. 1 proton, that means is equal to what? 1 electron. So that will be 1s1. Are we following? Now let's do for helium. Helium is going to be what? 1s2. Are we following? That means it has 2 protons, therefore 2 electrons. Now x can only take what? 2 electrons. Now let me come and put another key point here. You will see, later see it. X can take a maximum of 2 electrons. P can take a maximum of what? 6 electrons. D can take a maximum of 10 electrons. By the time we treat quantum numbers, you will know how we are saying S can only take a maximum of 2, how P can take a maximum of 6, how D can take a maximum of what? 10 electrons. So by the time we are treating quantum numbers after this video, you understand better. So F can take a maximum of 14 electrons. Alright, so we said F can take a maximum of what? 14 electrons. Alright, so now let's go. We said S can take a maximum of 2, P can take a maximum of 6, D can take a maximum of 10 electrons, F can take a maximum of what? 14 electrons. And we told you mainly we only have S, P, D, and F what? Orbitals. Now let's go. Before I do nitrogen, let's do lithium. Now in filling lithium, how would you fill lithium? To be 1s2. We already said S can only take a maximum of 2. That means it can't take more than 2, just 2. Then the next orbital, what was the next energy orbital? The next orbital we're going to have in terms of energy level now will be what? 2x. So after 1s2, you have to fill 2x. And lithium is atomic number 3. That means 3 electrons, 3 protons. So what will be here? 2x1. Are you seeing the trend? Now let's do for boron. Boron is 5. So how do we fill boron? 1s2, 2x2. S can only take a maximum of 2 electrons, remember? Then what will be the next orbital you need to fill? That will be what? 2p. And how many are we going to? We need to go to 5. Now we remember we said until all the electrons are filled up. So this is 5 here. We've already had 2, that's 4. That means the next one will take what? 1. But we already said P can take a maximum of what? 6, right? Now let's do nitrogen now, so that you understand. This is nitrogen. We have 1s2, 2x2, 2p5. This is 4, right? And we're going to 7, so this will be 2p3. I hope you get the idea. So after we are exhausting this p, the next thing we move to is what? 3s. After 3s, we move to 3p, then followed by 4s. Now in filling your first 20 elements, these are what you are going to be using: 1x, 2x, 2p, 3s, 3p, and what? 4x. This is what you will use in filling your first 20 elements. Are you following? These are what you use to fill your first 20 elements. Now, in filling 21 to 30 elements, are we together? 21 to 30 elements. These elements are very special. We call them transition metals. They are very special. Now, they prefer inner d orbital. Inner d orbitals. Are we together? Now, it's better that you put the d inside. Now, normally you would expect that, okay, I should say 1s, 2s, 2p, 3s, 3p, having a 4s, 3d. Some textbook put it this way. That's if you have filled 20, d we take from 21 to 30, quite alright. But some textbook can also say 1s, 2s, 2p, 3s, 3p, 3d, 4s. Now, based on this thing that we are having here, you know, it should be 3p, 4s, followed by what? 3d. But it's better in filling your 21 to 30 elements, it's better you put your d as inner d orbital, the 3d before the what? 4s. Are we following? You put the 3d before the what? 4s. Let's take note of that. Now, there's something I just want to bring out here now. Now, let's fill that for, let's do that of now let's just do something random. Let's fill argon first. Argon is 18, right? So how do you fill argon? 1s2, 2s2, Abina, 2p6, 3s2. Where are we going to? 18, 3p6. Check. 1s, 2x, 2p, 3s, 3p. Now let's count. 6 plus 2, 8. 8 plus 6, 14. Am I right? 14 plus 2, 16. 16 plus 2 is what? 18. You can see it's correct. Now if you want to fill potassium, what will it be? It will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. What of calcium? It will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now I'm going to take note of some key elements because of time. Now let's do scandium, which is, you know, I said our 21 to 30 elements are transition metals, which are always referred to as inner d orbitals. They prefer the inner d orbitals. Now you can fill it this way. You can say 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. That's quite alright. Some textbooks still do it this way, but I will prefer that you do this. I would prefer you just put 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Both of them are still correct. I was together, but it's preferably that you put your d as an inner d orbital before the 4s. Now the same thing for scandium, titanium. Now let's do for chromium. Let's do for vanadium. Vanadium is 23. Scarcity vomit, that's vanadium. So that will be 1s2, 2s2, 2p6, 3s2, 3p6. You can still put 3d, 4s, 3d, because I told you it should be inside. If you are still confused, do your 4s, 3d like that. So that means let's first fill 4s. 4s will be what? 2. Then 3d will be what? This will be 20. So this will be 3. Have you now? Now in doing your chromium too, what's chromium? 24. It will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d, then 4s. You come and put 4s2. That's 20 now. So this will be what? 24. You can count it. 4, 10, 12, 18, 20, 24. Alright, that's correct. Now, one would expect that your what element is that now? One would expect that your scarcity vomit crude, scarcity vomit crude. Okay. There's this particular element. Yeah, this is the element I'm trying to refer to. I'm coming. Let me show that I'm not made a mistake. Okay. Alright. Now you can see this copper. This is chromium, right? I said 3d4, 4s1. This is actually wrong. This is going to be wrong. this particular guy is going to be what? Wrong. Now because of stability, are we together? We said D can take a maximum of 10 electrons. Now because of stability, the half of 10 is 5. Are we together? So it's preferably that you write your chromium 24Cr. Due to stability issues, you put it as 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, then 4s1. This is infilling chromium. Same thing for copper. One would expect that if you want to write copper now, copper is 29. One would expect that it should be 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 4s, right? So this is 20, abi? One should expect that here should be 9, yes or no? But this is also wrong. This guy is also what? Wrong. This guy is also what? Wrong. Now, how do you feel copper? Copper will be 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 3d, then 4s. Now this is 4s2. No, this will be, you make this 3d to be 10 due to stability issues. It's near to the 10, which is complete. The 4 is also nearer to the half of the 10. That's why we are doing it. So this will be 3d10, 4s what? 1. I'm scared. So this is the ideal in filling your what? Copper. So this is the way you fill your copper: 3d10, 4s 1. Are we together? Alright, so now some of you might be confused, but just try and go through the video. Now let me walk you how to fill your 21 to 30 elements using a table. So if you want to fill 21 to 30 elements, so let me write the element. So what you just have to care about is this. This is scandium, scared, TT, vomit, crooked, moi, fish, coal, ni, copper, zinc. So scared, TT, vomit, crooked, moi, fish, coal, ni, copper, zinc. So this is 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now this is the 3D. Now one would expect this should be 1, 2, 3. I mean now for the 3D orbital, 4. Okay, we know here one would expect here should be 4. This should be 5. This should be 6, 7, 8, 9, 10. I mean now, but there's an exception to just only 2 guys. This is this 24 guy and this 29 guy. Now due to stability issues, so this your chromium will preferably be what? 5. Then this guy will also be what? 10. That's all. That's the only thing you need to change. Now let's, if you judge by this table, you can use this table to be answering your questions. If you cannot comprehend what I did the last time, it's just 2 exceptions to this, just the chromium and copper guy. So if I want to fill copper very fast, I already know that it should be 1s2, 2s2, 2p6, I mean now 3s2, 3p6, I mean now 3p6, 4s, 3d. I mean, but I said you should put 3d, 4s. I didn't know that. Okay, 4, 10, 12, 18, 20. Wait, this is the first 20 elements. Now, one should expect that for copper, this is 29. Yes, this guy should be 9. Yes or no? But no. You just change here to 10. Then if you do 2 plus 2, 4. 4 plus 6, 10. 10 plus 2, 16. Alright, 10 plus 2, 16. Sorry, let me do it again. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 10, 28. So this guy will just be 4s1. Same thing for, if you want to do for chromium. Ideally, you should have 1s2, 2s2, 2p6, 3s2, 3p6, 4s, 3d, but put 3d, 4s. Depending on you two, you can as well put 4s, 3d. Anyone is correct. So, but I told you that 21 to 30 prefer inner D, their inner D elements. So one would expect that, okay, here should be, if you put 2 here, one would expect that here should be, if I judge by this is 20, 22. I mean now, 4, 10, 12, 18, 20. One would expect that here should be 4, but no. This guy will have to be what? 5, judging by this. Due to stability issues, this will be 5, and this will be what? 1. If you add it up, it makes sense. 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 6, That's what 24. So it's as simple as that. It's as simple as that in filling your 21 to 30 elements. Alright, now the next thing we want to know, the next guy we want to do is what we refer to as Hund's rule. We've exhausted the time. So Hund's rule. So what's Hund's rule saying simply? It says that electrons are filled singly before pairing. Electrons are filled singly before pairing. Are we together? Electrons are filled singly before pairing. Now let's go. So what do I mean by this? If you want to fill nitrogen now, what's the electronic configuration for nitrogen? 1s2. No, nitrogen is 7, abi? 1s2, 2s2, 2p3, right? So if you want to fill it, this is s orbital, this is 1s orbital, this is 2s orbital, and this is what? 2p orbital divided into this. I'll show you how. Remember when I said earlier that P can take a maximum of 2 electrons? I'll show you why we said so. Now 1s, we said s can only take a maximum of 2 electrons, meaning it will go this way, the other electron goes this way. One will go this way, this will go this way. Have you seen? You fill singly, then you pair, you fill singly, then you what? Pair. Now you have done this 1s, you have done 2s. You first fill that of 1s before going to 2s. You have already filled it like this. It's complete. How many does it remain? It remains 3. Now what are we saying? What does Hund's rule say you should do? He says you should fill singly before pairing. If you go and do this way, then do this guy, you are wrong. What did you do here? We are this first subshell. You just put 2 electrons like that, then you come and put the remaining one like that. That's wrong. Hund's rule is saying that if you want to fill electrons into the atoms or into the orbitals, you fill singly before pairing. So what's the correct way? What do you do? 1s2. This is 1s2. This becomes what? 2s2. And this is where Hund's rule come and play. You fill singly before pairing. That means you should do 1, 2, 3. That is 1, 2, 3, 4, 5, 6, 7. This is the what? Correct way for filling nitrogen. Now let's do for oxygen. Oxygen is 8, abi? Now one should expect that it should be 1s2, 2s2, 2p4. So how do we fill? 1s2, 2s2. Now how do we fill 2p? To be 1, 2, 3. You first put it in a direction first. You do it singly, then you now what? Pair. If it is the other one, you pair this, then you pair this. So this is how you fill what? Oxygen. Are you seeing? This is the correct way of filling what? You fill singly before what? Pairing. So this is the second rule governing what? Electronic configuration. Now we have a third rule, which we call what? Pauli's exclusion principle. Pauli's exclusion principle. And what does it say? It says, it simply states, or it says that no two electrons in an atom, no two electrons in an atom can have the same set of values for the 4 quantum numbers. This is what this is saying. It says that Pauli's exclusion says that no two electrons in an atom can have the same set of values for the 4 quantum numbers. Now, what do we mean by quantum numbers? This will be treated in the other video. But let me just give you an idea of quantum numbers. These are electrons spinning. Now, for this 1s orbital, quite alright. These are 2 electrons. They are both in 1s orbital, yes or no? They are both in 1s orbitals. One is spinning up, the other is what? Spinning down. Quite alright, they are in the same energy orbital, which is 1s orbital. But their spins are what? Opposite. Are we together? Their spins are what? Opposite. That means no 2 electrons in an atom can have the same set of values for the 4 quantum numbers. So the next topic, we are going to just deal specifically on the what? On the quantum number aspect. But before that, there's some questions I would like us to treat. I know some of you are confused though. A lot of you, some of you are confused. Now let's do this thing. We are told to write the electronic configuration. We are told to write the electronic configuration for 1. Let me just put carbon. The next one, I'm going to just put F minus. The third one, I want to be very fast. I want to put O2 minus. Then the fourth one, I want to put Cu plus. The fifth one, I want to put Cu2 plus. Now let's go. We want to write the electronic configuration for these questions that have been provided to us. Now what's carbon? Carbon is IL in little beta boys. That's 6. So carbon is 6. So how do we fuse 6? 1s2, 2s2, 2p what? We want to get 6. So this is 4. We are going to be left with 2. So 1s2, 2s2, 2p2. Now let's do for this next one. The next one is a fluorine, but having a charge of -1. That's fluoride ion. And what do you mean by when you have something that's -1? It means it has accepted an electron. It has accepted an electron. That means initially fluorine is 9. Fluorine has 9 electrons.